Today we're diving deep into a topic that is as awe-inspiring as it is critical: the majestic Mount Rainier and the immense power of its debris flows. For scientists, students, and anyone living in the shadow of this active volcano, understanding these phenomena isn't just academic. It's essential. We're talking about something that could profoundly impact communities, and we need to explore why. When we think of a volcanic eruption, many of us picture fiery lava and ash clouds. But with Mount Rainier, there's another, often more immediate threat: Lahars, or volcanic debris flows. Imagine a concrete-like slurry of water, ash, rocks, and volcanic debris, hurtling down river valleys at incredible speeds. This isn't just a muddy river, it's a force capable of engulfing everything in its path: homes, bridges, entire towns. So, why is Mount Rainier particularly susceptible to these devastating flows? Well, it's a combination of factors. First, Rainier is an ice-clad stratovolcano. It holds more glacial ice than any other peak in the contiguous United States. When an eruption occurs, the intense heat can rapidly melt vast quantities of this ice and snow. This meltwater then mixes with loose volcanic ash, soil, and rock on the volcano's slopes, creating that super dense, fast-moving slurry we call a lahar. Second, Rainier's eruptive history isn't just about explosions. It's heavily marked by these massive debris flows. Geological evidence shows that lahars from Rainier have repeatedly surged down its flanks, carving paths through the landscape and reaching as far as the Puget Sound. We're talking about flows so powerful they've reshaped valleys and buried ancient forests. The Osceola Mudflow, for instance, which occurred about 5,600 years ago, was one of the largest in the world, covering hundreds of square miles and reaching the site of present-day Tacoma. This isn't just ancient history, it's a blueprint for potential future events. Now let's talk about the science behind these flows. Lahars typically follow river valleys because water naturally carves those paths. The physics are fascinating and terrifying. As these flows move, they gain momentum and pick up more material, increasing their size and destructive potential. They behave less like water and more like a liquid cement, able to carry huge boulders and trees. The viscosity and density are key to their incredible power. Understanding these mechanics helps us predict their paths and impacts. So what does this mean for the densely populated areas around Mount Rainier? Communities like Orting, Puyallup, and Sumner are built on ancient Lahar deposits. They are literally in the path of potential future flows. This isn't about fear-mongering, it's about being informed and prepared. The U.S. Geological Survey and local emergency management agencies take this threat very seriously, and for good reason. One of the most critical aspects of managing this risk is monitoring. Scientists are constantly watching Mount Rainier. There's an extensive network of seismic sensors to detect ground movement, GPS stations to measure deformation of the volcano's slopes, and even acoustic flow monitors installed in river valleys. These sensors are designed to detect the telltale rumblings of a lahar as it starts to move, providing precious minutes or even hours of warning. These early warning systems are invaluable. They can trigger alarms and activate evacuation plans, giving people time to get to higher ground. This is where community preparedness comes into play. Education campaigns teach residents about lahar evacuation routes, designated safe zones, and what to do if an alert is issued. Knowing your route, having an emergency kit, and practicing what to do can make all the difference. Beyond monitoring and warning systems, there are ongoing studies into lahar characteristics, modeling potential flow paths, and assessing infrastructure vulnerability. Engineers look at how to reinforce bridges and critical structures, while urban planners consider land use policies that minimize risk in high-hazard zones. It's a multifaceted approach involving geology, hydrology, engineering, and social sciences. For students, this presents an incredible opportunity for learning and even careers. Imagine being a volcanologist, a geophysicist, an emergency manager, or an urban planner, contributing to the safety of millions. The scientific challenges are immense, and the societal impact of this work is profound. Understanding plate tectonics, magma dynamics, glacial processes, and fluid mechanics all converge in the study of Mount Rainier's lahars. To sum it up, Mount Rainier is a natural wonder, but it's also a potent reminder of Earth's dynamic forces. Its potential for devastating debris flows is a significant concern for the Pacific Northwest, but it's a risk we're actively studying, monitoring, and preparing for. Knowledge is our best defense, and by staying informed, supporting scientific research, and participating in community preparedness, we can all contribute to a safer future. Thank you so much for joining me today to explore this vital topic. If you found this discussion informative, please hit that like button, subscribe for more educational content, and share your thoughts in the comments below. We appreciate your support.